Hello guys and welcome back to 737 DIY Sim here in the UK. I'm Carl and in front of me I've got two motorised throttle units from two different vendors. This unit is from FSC, this unit is from Cockpits for You. Cockpits for You is a little bit taller, but both units must come in at over 20 kilograms in weight, which means plenty of goodies for us to delve inside and see how they operate. Now both of these units are on loan from a UK sim centre. They're several years old and they have been abused. If you can imagine, people have tried to treat the flaps lever and the speed brake lever like a gear stick. Because they don't know to pull it up, they've basically ripped them out and both are suffering from user error. What you're going to see over the next few videos is a close-up of these units. Now, I want to express that they are old, they are tired, and they're not going to represent the latest versions on the vendor's websites. Now I've put both units side by side for a quick comparison, and the first thing you can notice straight away is the height difference between the two units. We've got the Cockpit for You on here, and the FSC, which is a little bit shorter, over here. Moving in closer for the Cockpit for You unit, you can see that the fuel select levers are level with the parking brake light. The parking brake light is slightly smaller than the FSC parking brake light, and the fuel select levers are well below the level of the parking brake light. I have no idea which is the correct way round, but that's how they are. Another difference are the trim indicator panels. They are flat on the FSC, but they do have a really nice all metal trim indicator in white. Moving over to the Cockpit for You unit, they've got this lovely domed slanted surface, and the only thing that really lets it down is the plastic indicator at the top. Just that the metal one on the FSC looks a little bit more professional. Moving on to the parking brake of the Cockpit for You, it is very substantial. That is a nice bit of metal to take all the abuse from people. It feels absolute rock solid. Moving over to the FFC, it's a lot thinner. However, this has got issues and it's not even attached anymore. So moving on to the flaps levers now. This is the FFC unit and it's built really substantial, but it has been abused. It is bent in all kinds of strange angles. However, the knob feels really good, and I can also feel it's not attached to anything on the inside, and you can see it's just fallen over there. Let's move over to the Cockpits for You flat lever. Now this hasn't been abused as much, but it certainly is very loose, and it's got a very weak spring pressure to pull it out, and there's also a lot of play in the gated areas, which is a bit of a shame. However, it looks like the pinion there, let me just zoom in a bit, there we go, is really badly worn, which might be causing the rock. Something we can sort later. Right next to that is the horn cutout switch. It's a metal unit and it feels quite good. And we've got the standard 6mm push button for the other unit on the FFC. Next up, I want to explain how the throttle levers feel. For the FFC unit, they feel really smooth and it just requires a gentle pressure to move them. I can hear the motor turning inside, but it doesn't affect the operation of the unit. Let's move over to Cockpits for You version. Now I've already played with this and hopefully you can, if I'm going to take the mic off and put it into the unit, here we go. So let me put my mic back on so you can hear me. Here we go. So the Cockpit for You, it has some serious force in manual mode to move the throttle levers. It takes a lot of force. So much force, let me go back a bit. I reckon we can lift a 20 kilogram unit off the bed here. See, that's how much force it's taken to move the levers. You could never do that with never with the FFC. There's nothing wrong with it. It's just a bit more than I would ever expect to feel to control anything. But it obviously works and the motor seems strong enough. So here is the back of the FFC unit. I'm going to come down right at the base here, and you can see that we've got a mains adapter plug here, cooling fan, USB and LAN. Moving over to the cockpits for you unit, coming down, and again at the base on the back side is we've got the mains connection with cooling fan, and this time what appears to be just a LAN connection. Also on the back side are the thrust reversers. Now these shouldn't operate in this position. You should be in fully idle position and then they should come up. In fact, they operate a lot easier there, but I think the mechanism may be broken. Let's go over to the back of the FFC unit and see that's thrust reversers. And do they operate outside the gate? No, but that is a substantial amount of movement. I think you can see the knob wobbling on the end there. Let's try this one. Yes, that one does operate all the way. Yeah, okay. This one's slightly better, but there's definitely a lot of issues there. It feels like something's come really loose. In fact, that one operates in any position. This one has just got a lot of play. Something else we're going to have to look at later on. Moving on from the thrust reversers, the last thing I want to look at is the trim wheels. Now the FSC trim wheels look absolutely gorgeous in gloss, but there is a reported problem with these, and that's when they're rotating in the cockpit, the handle flies out because it doesn't lock, and that's what happens in the sim. Moving over to cockpits for you, they feel really good in operation. However, the handle definitely locks in the in position. You have to lift it up and then out. And it also locks in the out position, which means then you can operate the trim. And it can be stowed lovely. That's a really good idea. We need to work on why this keeps falling out, just like that. However, I have noticed on the other side, oh dear, that grinding noise was the metal scratching my lovely desk. Never mind. The other side does appear to be a lot more stiff or stiffer in operation, so it stays in. However, there is no positive locking, I don't think. But we'll investigate that when we take it apart, which I think we should do now. Let me grab the cockpits for you one. Let's get it out of here. In fact, I'm going to leave the camera running just to show you how bloody heavy these things are. This is the FFC unit. So we're taking the FFC unit apart. I'm looking at it and we've got a small white top panel here. It looks like an access panel, and a large white access panel at the base here. I think the first thing we need to do is take the trim wheel off. Now this is where I really do need my glasses to see the tiny screws and up close things. So I think we can see here that we've got the black cap. I'm going to guess there's a big nut underneath there, perhaps a big lock nut. So we're just going to try and pull the cap off. Is it going to come? Yes it is. And there's a metal bar, no cap. Okay, in fact, if I show you this, that is actually meant for a lock nut. It's got a hexagonal shape inside, but there's definitely no lock nut there. But I can see 4 socket head screws, so let's get a Allen key in there and see what happens. Oh, well it turns, there's 1. I can't actually see because I'm at the wrong angle. 2, 3, and 4. Is that done any? Oh yeah, it's come really loose. Oh wow. So that is just a round cylinder centre. And then, oh that is clever. So as you tighten these socket head screws onto the shaft, it pulls this collar, this chamfered collar, onto a chamfer which expands it and traps it in the cylinder of the trim wheel. That is very clever. So I've got my electric screwdriver here and I've really grown to like this. I'm not actually sure. It's not very powerful, but it is quite good. And all we're going to do is put it in the screw holes. And away she goes. Got my little 3D printed tray. Really quite like that. That's part of the bamboo test samples. There's one screw. Always helps if I go the right way. And woohoo! Away she comes. Straight away we can see the internals of the left hand side of the unit, and we can see that we've got a solenoid valve here and a servo here. The parking brake. The parking brake is just a twisted shambles, really. I have absolutely no idea how that is supposed to operate. Okay. That makes sense. So that would sit roughly there, and then it would go down to there. That takes it off. I'm guessing it should have sat in there at one point. Wrong side. So what I'm going to do is bring close cam in and see if we can get any idea of how this was supposed to work while it was in one piece. So before we go any further, I'm just going to pin the parking brake with this Allen key unit I've just been using. And let's have a look. So in manual mode, it does that. That's very clever. So it just goes straight up and down. But how does the solenoid valve work? So the unit is on. The solenoid... Wow. Now that I had never have thought of doing. Using gravity to operate the parking brake lever, that is quite clever, because solenoids don't have a lot of power, not these ones anyway. So you can manually push through it, which is so clever, but when the solenoid operates here, all it does is it allows the parking brake lever to operate through gravity. Wow. You can see, shouldn't point with your fingers, you can see just how twisted this parking brake assembly is. However, it's still kind of functioning. I really like that. Oh, but it has failed. And that's what I would be worried about. I would be worried about, because it's just gravity, just how... Yeah. Okay, so it's working. There we go. Now it's better. Of course, if we straighten that out, that should work out a lot better. Isn't it amazing to see how others achieve the working mechanism? I'm absolutely blown away by that. I would never have thought of just letting it free fall into the off position. Let's get this lower panel removed and see what other things we can see. There's the side panel off. Now that is a big heavy chunk of metal. Really quite impressed. It's not even aluminium, that is actually steel. That's where all the weight comes from. Now looking inside, this is an engineering masterpiece. It is built so well, and it's built using really solid steel pieces. They have gone to town on this. What I love is you can instantly see that this lever here and this servo are connected, and they drive the trim. So we've actually got a servo driving the trim indicator here, and this long bar, can you see the bar on camera? Let me bring you in from a side view. So this bar here goes all the way through to the other side and connects to the other side here and operates the trim lever using just one servo. So for the speed brake, let's operate that. We've got a half camshaft gear here onto a spur gear, which drives a pot. And what I'm going to guess is that we've got a large gear onto a small gear, so the ratio of the pot uses its full range. So we're not going to use the 45 degrees that the speed brake moves. We're going to use near enough the full 270 degrees of the pot rotation, giving us a much better resolution. Also, you can see that we've got a drive belt that comes down to a motor down here. There we go. And that motor will automatically drive the speed brake. So while operating the speed brake, it'll only go as far as the flight detent. Now let's have a look why. Oh, I can see another actuator hidden in the back here on this little spring. So let me just operate the solenoid valve. There it goes, it clicked down. And yes, now we can move it all the way to the up position. Let go of that, it detents out, and now we're stuck again at the flight detent, and push it down. Yep, that's how it operates. The last one is the motor here. We've got the motor, it's a DC motor, direct drive, it is brushed, and it looks like we've got, I'm going to say, an encoder attached. So it knows its position, that's very important. It's also got 2 elongated slots so you can tension the belt behind, which we can't see right now. Let's get this trim wheel off and see what's hiding behind these panels on the right hand side. Now this side has been a lot, there we go. That side was a lot more difficult to get off. Okay, so that was a short bolt, short screw. Also I've noticed there's a screw missing here, so this may have been a part before. Off comes the panel, and this side is the flaps lever, which doesn't feel connected. I can't see anything moving with the flaps lever whatsoever. However, I can see an optical encoder moving at the back here. I'll try and get this in to show you. There it is, there. There's like an optical encoder. In fact, so does the trim wheel. Seems to have an optical encoder here. Let's get the lower panel off so we can see what's fully inside. That's this panel off. Obviously we've got the main driver board. We've then got the LAN board and the USB board just attached behind it there. There is the #1 throttle DC motor with encoder. Now, I actually wonder if that's a clutch unit or a gearbox attached to the DC motor there. We'll have to research that later on. So at the bottom here, we've got the PC power supply, and it looks like we're connecting straight into that. Next up, I'm going to try and get this slanted panel off here. It just seems to be held on by the 2 screws left and right here, and that should allow the whole assembly to get away, to move away. Let's give that a go. I think we may have to take this mechanism off to be able to get these parts out. Same for this side, there's just no way that's coming out. Oh, I'll take it back. There is some way it's coming out. So with that said, we should be able to do the same for this side. Oh yeah, easy when you know how. So what I'm trying to get to here is the thrust reverser mechanism, so we can repair them. Because I think that's the biggest repair on here so far, or it's the deepest one to get to. In the meantime, it looks like a lot more's got to come apart. So let's take the parking brake cover off next, and hopefully we can start getting to this panel here so we can get to the thrust reversers. Well, I don't know if you just saw that, but the big LED light is actually just a cover for a small one. Does the job. I'm going to cut some tie wraps here to allow the cables to be pulled through. There we go. So I've got a couple of options now which route to take. I think I'm just going to take most of these access panels off individually. I might have to take this front cover off here just so I can undo the cable looms going to the parking brake, and hopefully we can get that out of the way. But as this is part of the stand for the unit, this is going to have to go back on to help support the unit if I do have to take it off. I hope that makes sense. Let's just take a lot of screws out and see what happens. So there we've got the faceplate and a bit of rubber, which really makes the difference. It's like the dust cover for the levers. So all the cables, even though they've got quick release connectors on, you can't pull them out because of the way they're connected. But I do think they've got quick release connectors within the connector. I'll show you that in a second. I'm going to take a photo so I know which way round they go. Got it? And I think it is. It's these first four here. And are they quick release? Yes, they are. There we go. That should come off. Awesome. So I've never actually seen a connector with quick release pins on before. Pretty impressed. Does that mean we've got access to the parking brake now? No, it's still wrapped tight. So what I'm going to do is I'm going to lay it down on its side now. It's definitely getting lighter. So 1, 2, 3, 4, 5. It's only 5 screws. Off comes another really heavy panel actually. Oh yeah, now we can really start to see the guts. So let's snip these tie wraps. 1, 2, 3. Parking brake. There we go. That releases the parking brake out. Quite literally fell out. So what I'm going to do here is push the little tangs in and hopefully pull the parking brake out. There we go. Perfect. Now I do have a sneaky suspicion that to repair the thrust reverser levers, we actually have to split this clean in half, which is going to be a massive job. So yes, I am putting the side cover back on because I think we are going to do a complete tear down of this to get to the thrust reversers, which means the whole top assembly needs to be removed. Phew, let's do it. To be able to get this top section off, I think we've got to break down the handles now. So let's do that next. Let me go and pick those, whatever that was that dropped up off the floor. So that was the thrust reverser lever that fell out with all these bits. You can see that that's what's broken. That's probably why it's no longer working. So there's actually roll pins holding the two metal chunks together that create the throttle handle. 1, 2, 3. I think we'd have to knock them out to get those split. Also, I've got no chance of getting the wires out until this is split. So I'm going to guess you don't actually need to take them apart. And this center unit comes apart somehow. So I've just taken a little break off camera and waited for the cameras to cool down because they actually do overheat. I figured out that the top plate does break down, which is a huge godsend, so I don't have to strip the other throttle down. If we move in closer, there was this metal bracket here that went there, and all I had to do was remove the screws, the 3 screws in the front there, and then this whole top section, I'm hoping, is just going to pull away like so. So here is the decal panel with the rubbers. You can see that they're actually very badly worn. I'm dying to see how they've done their decal panels, how they're backlit. So let's take 3 screws out and find out. Straight away, it's exactly how I make mine. Bit of white perspex there, sprayed black on top, and then laser etched. And the same as the back panel. Now I wouldn't say this is 3D printed, I'd say this is actually injection molded plastic, but it does have the 12 volt LED strip inside to backlight it. Nicely done. I'm going to start with trying to get this cap off the trim wheel. Yeah, no issue there. Then we got a small washer and a large washer. So, one collar, two collars. Okay, I think that's given us access to the whole shaft now. Let's see if I can pull this belt off. Yep, there she goes. And I think this whole shaft is going to slide out. Oh, the bearing came out as well. I'm actually surprised that everything is still staying in position, even though the shaft is out, which is good. Okay, let's see if we can get this plate off here. There goes the encoder plate. Another washer. So now we've got the pass-through for the trim lever. That's just got an M10 nut. And that comes away lovely. I think we're ready now to pull off the flaps lever plate if it'll come. Okay, we've got the bearing. And I think we probably could remove this as one assembly. We can. And we turn it over. There we can see the flaps operation, and in between, I'll put this on camera now, we've got again a thick and a thin washer in between the flaps lever and the plate. Very important for when I put it back together. So off comes another spacer washer. Just going to put the attaching hardware in a bag with the component, so I know where it goes. Now we really can see how the thrust reverser mechanism works, that we've got full access to it. So you can't pull it up now because we've got the roller in the banana slot. As it goes in, we've got this vertical slot at the back here, and now it will raise up. At the same time, this bit of plastic with the gear on drives the pot round to give the reading. Absolutely amazing bit of engineering. It's a bit loose, we can tighten that up, but we'll definitely, I think, you can see how much play is in this part here. Really would like to change that for a bigger sized screw rather than an M3 that just bends. So mind you, someone must have put a horrendous amount of force into the thrust reverser in the off position to be able to bend it and break it on the other throttle. Well, I reckon we turn it around and we strip the other side off. So let's do the metal plate first. That's going to take the bearing with it. Perfect. So there we've got the parking brake solenoid. There goes the rod in there, and that just operates like that. We can try and sort that out later on. Here's our servo, and that drives the trim indicator here on this big gear here. We need to take this plate off. And now that really has broken it down. There's not much left to go, but here were the tie wraps that I was struggling with. There they go. So hopefully that can come out. So right here, we've got a connection in the cables for the parking brake solenoid, blue to black, and that's going to need to be cut to get the unit out. There's no other quick release connector in position. In fact, we can also take off the LAN connection board and the optical encoder ribbon cable. I am also tempted to get rid of the power supply, so we'll just cut that hot glue away. There we go. And there is our power supply, old PC one, just using a single connector. Well, I think at this point we might as well take the other side panel off and get rid of them. So off camera, this plastic washer came off the trim indicator. So we can take that off now, put it in the washer pile. So what I'm going to do now is I'm going to remove this bracket here, so hopefully we can stand it up on the base here again. Well, we've come this far, we might as well take the speed brake system off as well. 1, 2. More wires, which I think we're going to have to solve now. That is the parking brake micro switch. There's the parking brake plate. And of course the speed brake slide at the top there. Now we can really see the speed brake lever mechanism. So we've got the motor that drives it down the bottom. There's forward and aft. There's the pot, so we know its position. And here's the flight detent. We've got this solenoid here. That just basically moves out of the way. It allows you to go into the fully up position. And then this little roller slides on the metal plate here and allows it to go back into position. Then we've got this micro switch here, which operates by this noggin here as it contacts that position there. And that's going to be the arm position. Okay, let's take it apart. So we've got a thin and thick washer. Yep, there we go. That's going to allow the speed brake mechanism to slide off. And here's the speed brake mechanism. We've got the belt drive. We've got elongated piece of metal so we can lift the speed brake up. And then we've got the plastic gear attached to the metal. This actually weighs a fair substantial amount. So let's take off these mounts here. And out that comes. So there is our speed brake micro switch and speed brake solenoid. Good bit of kit. It's a new day here in the sim and we're nearly there. Just going to separate the two halves so we can see what's in the center section. To be able to do that, it looks like we've got to disconnect this motor, and it's not an encoder, it's actually a hall sensor, I believe. And then I've been wondering why there's a belt here onto this Allen key, and that's puzzled me for a few hours now. But in the end, last night, I just grabbed an Allen key and turned it and see what happened. And believe it or not, this is quite ingenious. I guess when the case is on, you've got no way to adjust anything. So you've got an Allen key hole in the case, and if you slacken it off, like that, now the throttles are really floppy, super easy to move. But when you tighten it up, now there's a lot of force. So I guess there's a friction plate in there, and it's tightening up the friction plate, so much so that they're really hard to move now. So that's the point of that. I do believe I'm going to take this mechanism off. Let's pull the belt off. Now that is quite a unique shaped nut. Wow, bit of engineering's gone into that. Yeah, so we've got the little shim, big washer, and I'm going to guess that's a concave, yeah. So I'm guessing that's how they achieve the friction. There's a concave washer there, which I guess compresses under load and applies friction to the shaft. Now I would have guessed that this whole plate comes off, if I've undone everything. And that is the heart of the machine. We've got our throttle levers, which I believe we can get off now. Wow. And there's our friction plates. Wow. So that's where all the dust is coming from. So here you can see the friction pad, which must allow the manual movement of the throttle when the motor's engaged, so it just slips on the gear. Let's pull that back off. If I pull off the number 1 fuel cut-off lever, so it's got a drum plate that the friction plate rides on, and then we've got another friction plate here. Oh wow, that's actually a bearing. Hopefully you can see that not only do we have a rotating bearing there, but that gear can also rotate in the unit. And what I'm noticing here is that the gear is catching on this metal part here, and that's without the belt being on. Let's have a look at the belt. Have I picked up the right one? I think I have. Yep, so we've got the metal tongs here of the fuel cut-off lever. They're actually contacting the belt, and that's what's causing a bit of rubbing. Very minor though. And that thing is absolutely filthy. So here now we can see how the fuel cut-off lever works. We pull it out because it's on elongated slots with this spring here. We ride it up. That's on the on position. And as we come down, we've got this plastic nodule here that activates the micro switch in the idle position. It's very dirty. That is free to move nice and easily. In fact, there we go. So there's the motor driving the throttle. If we hold the motor still as if it was engaged, you can still move the throttle lever. So that acts as the clutch. We've got a bit of damage here as well, look. It's only the outer sheathing. There's no damage to the inner conductors or insulation. That's cool. So that just needs adjusting. We need to clean this thing up, get it back together, and try and sort out the thrust reverser levers. Okay guys, I think we're going to call an end to this video. That's as far down as I need to strip these units. I can get to all the parts now to replace any damaged parts or make adjustments. That'll be in the next video. I'm going to go away and get cleaned up because my hands are absolutely filthy. I'm a greenie, you know. That's an avionics engineer. I don't like getting dirty. I'm going to go and wash my hands, and I will catch up with you guys in the next video. Until later guys, sim out.